Good afternoon. Can you hear me? Hello? Can you hear me? Good afternoon, guys. Joshua, can you hear me?
Yes, sir, we can hear you.
Can hear. Thank you. Okay. Sorry, man. I was struggling to connect here. I don't know what's wrong with my Wi-Fi here. Sorry for keeping you waiting, but we'll start. Right. So we're looking at the consolidation exercise. We're gonna be revising the consolidation exercise 20. All right, so let's start. Okay, just a second. I want to do something here. Just 1 second. Okay. Okay. Let me just open this. Okay, right, so let's start. I hope you can see the slide that I've opened here. Right, so we start with multiple choice, number 1.1. For which one of the following quantities below is the correct unit of measurement given? All right, so you're given current, energy, potential difference, and resistance. So here you're given current, it's ampere per second. That's wrong. All right, current, it's I is equal to Q over T, which is charge per unit second or charge per second. So that one is wrong. Next one, we've got energy, kilowatts. Energy is not measured in watts. Those are units for power. All right, potential difference, it's volts. That's correct. All right, resistance, volt per second. That's incorrect because resistance is equal to V over I. It's volt. Actually, it's volt per ampere, and ampere is equal to coulomb per second. So that unit becomes incorrect then. Right, we move on to the next one. So the correct answer for 1.1 is C. We go to 1.2. Consider the circuit diagram below. How will the, okay, so you're given A1, it's measuring the total current coming from the battery. And when it gets here, it splits into two, A2 and A3. So current splits here. And when you look at the resistance, 2:4, the one with the smaller resistance gets more current. So A2 is greater than A3. Why? Because the smaller the resistance, the more the current that flows. Right? So A2 is bigger, A3 is less. But when I add A2 plus A3 gives me A1. So let's look at the answers. How will the readings on the ammeters A1, A2, and A3 compare with each other? Right? So the first one is saying they're all equal. That's wrong. Right? Because here current splits here, so they cannot be the same. So A is out. We move on to B. B says A1 is the sum of A2 and A3. That's correct because current here splits into two proportionally. So A2 plus A3 gives us A1. All right, next one says A2 plus A3 is greater than A1. A2 plus A3 gives us the same as A1. So this statement is wrong here. A2 plus A3 must be equal to A1 because A1 is the one that splits here. C is incorrect. We go to D. D says A1 is greater than A3 and A3 is greater than A2. Right? This statement here, it's incorrect. Why is it incorrect? It's saying A1 is greater than A3 and A3 is greater than A2. That's not right. What is supposed to happen is A1 is greater followed by A2 because A2 has got lower resistance, so it will get more current. And the A3 will get the least current because it has higher resistance. So that statement is incorrect. If these two were swapped around to say A2 comes where there is A3, A3 goes, then that statement becomes correct. So this one is incorrect. Right, so that's what you get there. There were only two multiple choice, right, for electricity. So you get your 4 out of 4. Then we move on to question number 2. Question number 2, I'm going to be alternating between the question and the answers here. All right, where I need to calculate, then I'll do the calculation. 2.1, two identical bulbs, and the identical bulbs is written in bold letters so that you take note of that. Identical means they've got the same resistance. So A and B have got the same resistance, as well as a measuring device Z, and are connected to a battery as shown in the circuit below. The switch is initially open. So we start with an open switch, all right? 2.1.1, which physical quantity will device Z measure when the switch is closed? So you look at the arrangement there, it's in series. This device is connected in series. And the two devices that measure quantities, we spoke about an ammeter and a voltmeter. And an ammeter is the one that is connected in series. So it means this should be an ammeter. If it was a voltmeter, it's supposed to be across, it must be connected parallel. So Z must be an ammeter. So which physical quantity will this device measure? You cannot say ammeter. We need the physical quantity. So the physical quantity is current. So please be careful with this question here. Z is an ammeter, it measures current. The question is asking for the quantity that it measures. So someone is bound to write ammeter. If you write ammeter, you're wrong, because that's not a physical quantity. That's an instrument that is used to measure current. Right, we move on to the next one, 2.1.2. Give a reason why the brightness of the bulbs will be the same when the switch is closed. All right, so you look at these two bulbs. Number one, they're identical. Identical means they've got the same resistance, right? That's point number one. Number two, they're all connected in a series. When resistors are connected in series, they get the same current. Since they're identical, they also get the same voltage. So the way you give the answer will depend here. Maybe it's three ways to give the answer, right? So number one, the bulbs are identical and in series, all right? That's a mark. Or you can say the same current flows through each of the bulbs. That's correct. Or you can say the same amount of charge passes through each of them in any given time. So they're getting the same amount of charge, which is basically current. You are defining current in a different way. So they're all getting the same current. Or you can say the potential difference across each of them is the same, hence current is the same. So since there are two resistors in series, they are potential dividers. Since they are identical, it means they'll get the same potential difference, hence their current will be the same. Clear?
Yes.
Right. Okay, we'll move on to the next one. A third identical bulb is now connected in series with the bulbs A and B in the circuit. So it means somewhere around here, we can put a bulb, or we can put it here. Anyway, we can put a bulb there so that they are now in series. Three bulbs are in series. Let's look at the question. 2.1.3, will the brightness of the bulb increase, decrease, or remain the same? What do you say here? What do you think will be the answer?
Decrease.
Decreases. Why does it decrease?
Because when you add more bulbs, then current is like divided into each of the bulbs, making them all equal, but less, like
Okay.
less brightness.
Less current. Okay, right. So it's correct. Current is not going to be divided here, because remember, resistors in series, they are not current dividers, they are potential dividers. So basically what is going to happen if you put another bulb in series, it means the total resistance increases. When total resistance increases, current must decrease. Yeah? Right.
Yes.
So the answer is decreases. That's correct. Answer is decreases. Just watch out for the explanation there. It's because the total resistance increases, therefore the current will decrease. Clear?
Yes.
Right. We move on to the next one. The next one, 2.2. In the circuit below, let me just check the way they, okay, here they say it decreases, so it's fine. Okay, we move on to 2.2. In the circuit below, potential difference V1 across the battery and the potential difference V2 across the 4 ohm resistor are unknown. Right, so you're given an open switch, you've got your V1 across the battery, you've got your 4 volts across the parallel. And please note this 4 is for 6 and 2. So it means the 6 ohm will get 4, the 2 will get 4. Remember, resistors that are in parallel, they get the same. They are current dividers. Therefore, their potential difference remains the same. Right, then you've got your 4 ohm here, and the reading there is a V2. Right, you've got your V2, that's the voltmeter reading that you have. Okay, right, that's only the information that we have. Let's move on. When switch S is closed briefly, the potential difference across the parallel combination is 4. So when you close the switch, the reading here is 4. Okay, define the term potential difference. Define the term potential difference. Like I said, you go back to the formula for potential difference. Potential difference is V is equal to W over Q. W over Q, which is work done per unit charge. So potential difference across a conductor is the energy per unit charge flowing through it. All right. Or if you don't like the word the energy, you can use work done. So, or you can say work done per unit charge across the conductor. And please don't forget where we're getting this. We're getting this from this formula here. Let me just put it here so that I talk what people will understand. It's coming from this formula here. Let me just open quickly. Okay. It's coming from this. V is equal to W over Q. W over Q. That's where we're getting it. Potential difference is work done per unit charge. So use this, you must use your data page to define potential difference. And don't forget current as well. Current, they normally give it to you like this. Q is equal to IT. Current times time. So if I make current the subject, I'm going to divide both sides by T. So therefore, my current is equal to Q over T, which is amount of charge per unit time, or charge per unit time. Right, so that's what you have. That's where we're getting that definition there. Right, moving on. Right, moving on. Let's look at the next question. So we have defined potential difference for 2 marks. Please note definitions, either you get full marks or 0. So either you're right or wrong. So be careful, you are defining it correctly. Calculate the effective resistance of the 2 ohm and the 6 ohm resistor. Right, so you check your 2 and your 6, they're in parallel. So you know the formula for adding in parallel. What is it? 1 over R parallel is equal to 1 over R1 plus 1 over R2. You get a mark for that. Then you substitute. It's going to be 1 over 2 plus 1 over 6. All right. Using rules of fractions, right? You're going to add that. Then basically what you're going to have, let me just do it here quickly. You're going to have your 1 over 2 plus 1 over 6. It's not a continuation here. I'm just doing that quickly. 1 over 6. Your LCD, it's a 6. 2 into 6 goes 3 times. 3 times 1 is 3. Plus 6 into 6 goes once times 1 gives you 1. Your answer there is going to be 4 over 6. Then you flip it. Right? Please don't make it an equal sign here. You flip this. Right? You're going to have to flip this. Right? You flip the 2. Therefore, it becomes 6 over 4. And 6 over 4, what is 6 over 4? Please don't put an equal sign here. That's why I'm putting implication sign. 4 into 6 goes once. Remainder 2, 4 into 20 goes 5 times. Right, so it's 1,5 ohms. That becomes your answer. Please don't leave your answer is 4 over 6. That will be incorrect. So your answer is 1,5 ohms. That's what you get. Okay, right, we move on. Okay, so your answer is 1,5 ohms. Yes.
When you doing the substitution of the flipping,
yes,
it always has to be an uncommon fraction.
Either way, it can be either way. For example, yeah, let me see. Yeah, it has to be a common it has to be an improper fraction. Did you want to say improper fraction?
Yes, sir.
Yes,
Sorry.
yes, it has to be that. So let's say if it was 1/3, then it becomes 3/1. If it was 3/1, then it becomes 1/3, something like that.
Okay, sir.
Yes, thank you. Or on your calculator, there's a button that you have. You can simply press that button as well. I think on the calculator, there's a button like this, x to the power -1. If you press that button there, x to the power -1, the inverse button, so it will flip it for you. So you don't have to worry about that. Sometimes your answer is a decimal, so you don't know what's the fraction. On your calculator, you can simply press x to the power -1, then it will take the answer that you have and flip it for you. Clear?
Yes, sir.
Good. Who's talking, by the way?
Kimberly.
Kimberly. Okay. All right. Let's move on to the next one, 2.3. 2.3, we have the reading on voltmeter V1. Reading on voltmeter V1. Right. How do we get the reading on voltmeter V1 here? That's the voltage across the battery. What are we going to do? What do we do? How did you do this one? The reading on voltmeter V1, the battery. We're not given the battery. How did you do this?
I think because voltage and parallel is equal.
How many marks was this? It was 4 marks. How did you do it? Did you leave it like that?
I know.
Yes, sir.
Yeah, tell me, how did you do this one? Because it's a tricky one.
Yeah. Ish.
I just left it out, sir.
You left it out. Joshua? Owen, what did you do here?
I also left it out.
You left it out. Okay. All right. Let me take a screenshot here. Then I work it out. Okay, just a second. You need a screenshot for this. I need to explain this. Tricky. Okay. Quickly, let me just open this, taking time. Okay, there we go. All right. I need to explain to you this one. Right. Let me just open 2 pages here. Okay, Joshua, you say what? 10.67. That's what you got. Joshua? What did they do here? Okay. All right. New page. Okay. Right. Let me explain to you here what we have. Right. In the previous question that we've done now, what is it that we got? We got the total resistance here. The total resistance here is 1,5. So just write it here. Total resistance is 1,5. Right? So if I've got the total resistance on the parallel is 1,5 ohms. So what is the total resistance for this circuit here? R total is going to be equal to R parallel. R parallel plus the R that is in series there, R series, which is going to be equal to 1,5 plus the 4. I'm talking about this one is the one that is in series here. So plus the 4. So our answer becomes 5,5 ohms. That's the total resistance, 5,5 ohms. There are actually two ways of doing it. Right now, my challenge is I don't have current here. So I need the current that is going to flow here. So what am I going to say? I'm going to say, for me to get the current, I'm going to use the parallel, because parallel, I'll get the total current that is flowing in the parallel. So I'm going to use R is equal to V over I. V over I. The resistance for parallel, I know it's 1,5. Right, is equal to V. My V, I know it's 4 volts. So I'm going to say 4. Divide by the current. Then my current becomes, I make current the subject of the formula. So it's going to be 4 divided by 1,5. 4 divided by 1,5. 4 divided by 1,5, which will give me, let me just do that quickly. 4 divided by 1,5, yeah. Right, I'm going to get 2,67. So the current that I'm going to get is 2,67. I hope I'm right. Right, 2,67 amperes. That's the current that I have. The current that is flowing for the total parallel is the same current that is going to flow in the 4 ohm. Is the same one that is going to flow through the battery. Now I've got total current. Now, so this I that I have here is total current, this one. So I've got total current, I've got R total, therefore I can get V total. So I'm going to say V total is equal to the formula for voltage. I'm using Ohm's law. It's going to be I total multiplied by R total, so that I get the total voltage across the battery. The voltage across the battery is the total voltage. So the T here means total. So I'm going to take my I total, which is 2,67, multiply by R total, which is 5,5. Right, then my answer, I'm going to get 2,67 multiplied by 5,5. That will give me
14,69.
14,69, correct. 14,69 volts. Right, so Joshua, you got 10 point something, so 10 point something is not correct there. Right, but if you check now, the work that I've done here, it's worth more than 4 marks. This is work for more than 4 marks. The total marks that were given here were 4. So it means there's a shorter way of doing it. What is the shortest way of doing this? Is the following. I'm going to do ratios here. I'm going to do the ratio of the parallel is to this, because I want to know V2. So I'm going to start by calculating V2 first. When I know V2, then it means if I add the V on the parallel plus the V on the 4 ohms, it will give me V1, because I know resistors that are in series. This one is in series with these two that are in parallel. I know resistors in series, they are potential dividers. So it means the V1 from the battery was split 2 ways. If I know that this one is 4, if I can get this one, then I can add V1 plus 4 to give me V1. So that's what I'm going to do. So my first statement, I'm going to say, for me to get V1, I need to add V parallel plus the V on the 4 ohm, or which is our V2. For me to get V1, I need to add the voltage here and the voltage here. But for V parallel, I know it. What is the V parallel? I know it's 4. So I'm just going to say 4 plus. But the one for V2, I don't know it. So what am I going to do? I'm going to use ratio. I'm going to do V parallel is to V2. I'm going to use the ratio. Right, let me write it in blue. Right, so V parallel, I got that one. V parallel I'm given, I've got a 4. So here it's going to be 4. Sorry. Okay, for me to do the ratios here, let me just repeat this. I need to start with the resistance first, because the ratios that I have, it's only for the ratio that I can use is the one for resistance. So I'm going to use the resistance first. So the ratio for resistance here, the ratio for resistance, it's R parallel is to R series, or R4 ohms. I know the ratio there is 1,5. That was the one that we calculated here. 1,5 is to 4. That's the ratio that I know. So it's 1,5 ohms is to 4. Now voltage, the voltage that I have here is 4. What do I expect to get here? Right, 1,5 is to 4. What if I've got 4 volts? How much am I gonna get here? I expect to get more. I expect to get more here, more than 4. So for me to get more than 4, what I'm gonna say? I'm gonna say 4 divided by 1,5 multiplied by 4, right? So basically I'm gonna, what I do, I cross multiply. I'm gonna multiply this 4 by the 4 and divide it by, this way I'm gonna divide with the 1,5. That's how I get the answer here. So I'm gonna say 4 over 1,5 multiplied by 4. Multiply by 4. That will give me the answer. Right. So 4 over 4, it's 4 times 4 divided by 1,5. Right, my answer is 10,67. I get 10,67. Right. So 10,67 is the voltage that is flowing across V2. So here I've got the voltage here, 10,67. That's the voltage here. All right, volts. But now I need the voltage across V1. Am I right? That's what we're looking for. Right, if it's V1, let me just double check on this question here. I think it should be V1. V1, yes, V1, which is across that. Right, so what am I gonna say? I'm gonna now add, I'm gonna add V on the parallel plus V on the 4 ohm to give me V1. So I'm gonna go back on that statement there. Now I know this is 10,67. I'm gonna add the 2. All right, when I add the 2, my answer becomes 14,67. Right, volts, which is the same answer as the one that I got this side here. Right, so this one is a long way and this one is a shorter way. I'm not sure whether this was 6,9 or because of that rounding off that we got there. So this one is going to come at 6,9 because here we rounded off here. So that rounding off, there are numbers that we ignore. So it perpetuates an error into the next answer. That's why this one is 14,69 and this one is 14,67. Is that understood?
Yes, sir.
Yeah?
Yes, sir.
Okay. Zinedine, are you fine?
Okay, yeah, sir.
Okay, all right. Let's continue then if you're fine. I hope the others are okay. Jolie, Shade, if you have a problem, just send a message. Owen, Sunny, and Galaxy State. I'm not sure Galaxy State, who's Galaxy State here. Okay, all right, fine. Let's move on to the next one. We've got about 10 minutes left. You guys, if you need more time, we can maybe when the time expires, we can join again so that we finish this paper here. Is it fine?
Yes, sir.
Okay, so when the time runs out, you're gonna go out, then come back again, then we continue so that we finish this revision, yeah. Okay, let's move on to the next one. 2.2.4, reading on voltmeter V2. reading on voltmeter V2. We have answered that one now, isn't it? All right. V2 we saw it's 10,67 already. Let's just check on this memo here what do we have here. Right. So for 2.2, they got the 1,65. Then they got the resistance for parallel 1,5. Oh, this is okay. Here they said VP, it's R parallel over R total multiplied by V total. All right. Here they've just made an equation here. They've made an equation of which you need to understand this. Basically, they've said R parallel over R total multiplied by V total must give us the V parallel. I don't know if you understand this. Do you get this? Do you get this one here? They've made a fraction of the total to say R parallel over the total resistance multiplied by the voltage will give us the voltage of the parallel.
Yeah.
Okay, let me write it down so that you understand what we're saying here. Let me go back to this slide here. Okay, so basically what they are saying is this. The total resistance of these resistors here, if we add the resistance here plus the resistance here, it's going to give us R total. So let me rub this here so that you understand what I'm trying to say. Right. We have got R total. So we are saying for us, we can create a fraction for resistors that are in parallel. Right, so we're gonna say that we have got R parallel value voltage. So we are saying the resistors that are in parallel, we make a fraction out of this. Total resistance of resistors in parallel over the R total of the circuit, all right? Which happens to be, we know the R total here it's 1,5 plus 4, which makes it 5,4. Sorry, 5,5. Right, and the resistance for the parallel resistors here, we know what is it? It's 1,5 multiplied by V total here by the battery, because we know resistors that are in series here, they're gonna share the voltage here. So if we do a fraction of total resistance and multiply it by the total voltage, so we're gonna multiply by the total voltage. This is going to give you the voltage across the parallel. But the voltage across the parallel, we know it. It's 4. So here we're going to have 1,5 over 5,5 multiplied by V total, which is the one across the battery, which we do not know. All right. So multiplied by V total, which is the one that we are looking for, is equal to the voltage across the parallel we are given, it's 4. Then you make V total the subject of the formula. So what are you going to say? You're going to cross multiply by 5,5. So you're going to take the 5,5 that side. Then you're going to divide by the 1,5 here. So your V total is going to be equal to 4 times 5,5 divide by 1,5. That will still give you the same answer that we got there, right? Which is 14,67. So you can do it as a fraction, create a fraction, and it will help you to get the V total. Or you can do ratios, or you can use Ohm's law. You can use R is equal to V over I, like what I've shown you there. So you've got 3 options for getting this answer here. So you go with the one that is easy for you to understand. Right, so here on the other one is the other option that I've done, where you must calculate the current, total current first, right, which happens to be 2,667. Here they rounded off to 3 decimal. then your final answer, you round it off to that. So mine, I didn't do it like that. That's why I've made that error. So I think we can learn from here. Round it off to 3 or 4 decimal places so that at least that error is not going to be added into your final answer, right? Then after that, you're going to get your V2, which is the voltage of the 4 ohm. Then you're going to get the voltage there, 10,67. Then after that, you add the 2, then it gives you that. So that's the second option. So actually, there are 3 options for doing this one. Yeah, right. Then we move on to 2.2.4. 2.2.4. It says the reading on voltmeter V2. So this one is covered already. You know how to do this. Because in the 2 answers that we have done that. All right. Okay. Something happened here. Let me just close this. Let me just try and open this again. Something has disappeared on my thing here. Okay. Okay. Right. So we continue from this. 2.2.4. So there are 2 ways for doing it. For example, if for you to get V2, you can take the V total that you now have minus the V parallel. Then it will give you 10,67. But from the previous answer, we already have that. So you can just choose maybe this. You can still use that to give you 10,67. Or if you are using this approach here, then you, instead of doing R parallel over total, now you can just use R series, which is the 4 over the total multiplied by the total, because the total now is here. You've got your 14,67. Then you can do that. So it will be 4 over the total resistance, which is the 1,5 for parallel and the 4 ohm resistor, then multiply by the answer that you got up here. And here it says positive marking. What is positive marking? Your answer here can be wrong here. As long as you do the right way, then you still get your 3 marks. So if your answer, let's say here was 10, like maybe someone got 10,67 here. If you're gonna put 4 over 1,5 times 10,67, then you're gonna get all these marks here, because we don't mark the answer. We mark the understanding of the concept. So you're gonna get it right here. Clear? Hello? Are we
Yes.
together?
Yes, sir.
Yes,
Right.
sir.
Okay. We have got 1 minute 28 seconds, so I'm gonna continue. But you guys, when we got cut, then we're gonna come back again and do this again. Are we together? So that at least we can finish this paper. There's only 2 more questions left, number 3 and number 4. Then we are done. Clear?
Yes, sir.
All right. Or maybe I must just end it here so that we know we're going to start on number 3. So I will stop the lesson now in this last minute. Then you guys, you rejoin again. Clear? Okay.
Sir.
All right.